invitation to be part of this event. And the floor is yours. And in the end, the participants can have some questions and comments. Thank you, Professor.
Try to. Okay, can you see my screen?
Yes, Professor.
Okay. Good morning, everyone. I know a lot of people here, so it's a pleasure for me to present here. Good morning, Arion, Enea, Arturo, and everyone in the conference. It's a pleasure to be here. And maybe next year we can be together in a face-to-face conference. So anyway, I'd like to talk about historic masonry and basically the difficulties that as a structural engineer we often face when we deal with this kind of, let's say, material, if we want to call this as a material. So basically, I like to show this photo when I start this presentation, because this photo can be a little bit problematic for those people who like to model, to do numerical modeling. If you look in detail to this building, it looks like theoretically a regular structure with what, eight windows, equal spacing between one window and another. But if you look in detail the masonry material, you will see some difficult thing to take into account in a numerical model. So different types of masonry, joint, you know, there is bricked image how difficult this can be. I'm moving from here in a place where the connection is stronger. Okay, so basically at the University of Perugia we have proposed a method to in a way have a structural assessment of historic masonry. So when we talk about historic masonry, the mechanical properties can be much more scattered compared to any other construction material. So even if we consider concrete or we consider timber, the scattering of the mechanical properties of this material are lower. So we have perfectly cut stone masonry, we have thick joint, we have dry masonry, stone masonry, we have pebbles, we have rounded. So it's a very difficult situation, and the mechanical properties as a consequence as a very large scattering. And a similar situation, maybe a little bit better, can occur also in brickwork masonry. So if we look at this, for example, 5 different bonding patterns of brickwork masonry, you may note that if you look with attention, that the bonding pattern is different.
Sorry, Professor, to interrupt. Okay, because it looked like your slides were not moving. Okay, it's okay now. Thank you.
Sorry?
Previously it looked like your slides were not moving.
Oh, they are not moving.
Okay, it's okay, it's okay. Now it's okay.
Is that okay now?
Yes, yes, now it's okay.
So did you note this picture at the beginning?
Yes, yes.
But the second slide, no.
Not the same.
Okay, so was about different typologies of stone masonry, and here different typologies of bonding patterns. All these things may have sometimes a critical effect on the mechanical properties. So when we talk about historic masonry, and for example, here you can see a cross section of 1 meter thick wall that from an initial assessment, you can say, I have a 1 meter thick wall. As a consequence, I can assume the mechanical properties are good for such a large wall. Then when you go into to look at the cross section, you may find voids, you may find different layers, you may find a lot of situations that can completely change your assessment of that wall. This is unfortunately what we very often can occur on historic masonry. So in order to do a structural assessment of the masonry, about 10 years ago, and we started proposing a method that is a visual method to assess the mechanical properties of masonry. You will see this method as some, of course, limitations, but also it's a very important to say that we really use all the structures, consideration, and methods to gain as much as possible information from the type of mason. So, for example, looking at the face of the mason, if you have courses, if you have stone masonry, this method will take you to have an estimation of the shear strength, of the shear modulus, and also of the compressive strength of the masonry. I just will talk about this in the next slide. So basically, what we want to avoid is to do on-site testing of masonry, because on-site testing of masonry is a very destructive testing. So it costs a lot of money. It causes damage. It causes irreversible damage to the structure. So it's very rare that, for example, conservation bodies will give you authorization to do such destructive testing on masonry. So to avoid these kind of things that we have done initially on a lot of buildings, and the information that we got from over 100 tests on site, because we cannot do laboratory tests for historic masonry, because historic masonry cannot be transported to the lab, because the vibration will cause irreparable damage. So you need to do on-site testing. So what we have done, we have calibrated our visual method based on the experimental results. Okay, so we have a method that is a visual method that I'm going to talk next, that has been calibrated using about 100, that is a large number of experimental results, mainly from the center of Italy, that can be considered a limitation. So just to understand what is the concept. So look at this simple, let's say, cantilever wall, vertical cantilever wall, right? So we have the same wall with the same loading condition, that is a uniform distributed horizontal load. And for example, we would like to know the capacity of this wall. And you can see that the masonry, the bonding pattern is different here. So what is the capacity of these three walls. Okay, so Professor Geoffrey, that made a lot of tests about 20 years ago, discovered that the capacity of the wall is in between the two limit situations here, the situation of a solid single leaf wall, and the other limit is a double leaf wall. And the load versus horizontal movement of the load is a line, it's a bold line that is in between the two, and it depends on the bonding pattern. Okay, so this is something that the bonding pattern can play an important role in the assessment of the capacity of the wall. In this case, was a rocking, is an overturning of the wall, but this can be similar for the shear strength and the elastic modulus. So the masonry quality index, that is a method to give a structural assessment, the masonry under analysis, consider 7 different parameters. These parameters are the mechanical characteristics of the units. So is it stone or bricks? And we will discuss this in a few minutes. The dimensions of the unit, they are very small or very large units. The shape of the masonry unit, so if it's a perfectly square masonry, the level of connection between multi-leaf walls, the horizontality of the bed joints, and the scattered characteristic of the head joints. So let's look, this is basically, we look at 7 different parameters, and for each parameter, we consider a possible outcome that will be fulfilled, partially fulfilled, and not fulfilled. So I want to show you what is this method and how does it work. So what are the 7 parameters? These 7 parameters come from historic manuals, from the so-called rule of the heart, starting from an ideal masonry was a perfectly masonry according to the historic manual how to make a perfect wall. These are the rules of the heart, and then we consider if the rules of the heart are met or not in the masonry under analysis. So the first analysis, the first parameter is the conservation state.